We are going to be looking at solving a new type of equation involving square roots. And remember, a square root, and this is from the first unit and also from last year, a square root is just one type of what? What do we call those things that have that symbol and they could have a 2, a 3, a 4? Radicals. Okay, they're all called radicals. Specific names are square root, cube root, fourth root, but they're all called radicals. Okay, so I think it probably makes sense what a radical equation is, and we're going to focus on square roots. It's an equation that has a square root in it. Okay. Now, you could probably, I'm not going to fill this in just yet, because I always like to sort of look at an example first, or even do an additional one. Like if I said this, just a separate question. You don't have to write this down. You can write it. So if I gave you this, remember the goal of equation solving is to get x by itself. Right now, there is only one thing with the x. And what do we always do? We always do the inverse of whatever's there to get rid of it. So like if it's x plus 5, then I do minus 5. If it's x divide 5, then I do times 5. Okay? What do you think you do here to get rid of the square root? Square. Because the square and the square root cancel each other out. And whatever you do to one side of the equation, you have to do to the other. So we end up with x equals. And does that make sense? Does the square root of 9 equal 3? Yeah. So that's the only additional step. What if I gave you this one? What do you think you do first? What's that? Yeah, because the general rule is kind of like you want to get rid of what's furthest away from the x. This square root is right on top of the x. This is a little bit further away. So we want to get rid of this first by subtracting both sides by 5. Okay? And now what do we do? Square both sides. And we get x equals 64. Yes? And does that make sense? Does the square root of 64 plus 5 equals negative 3? You sure?
Oh, 8.
Square root of 64 is 8. 8 plus 5 is not negative 3. So this doesn't work. That is going to happen sometimes with radical equations. You will actually get a solution that doesn't work. Okay? And it especially involves when you're squaring negatives to get x by itself. Okay? It'll change the answer and it won't work. So this is something we call an extraneous root. It's a solution that's not actually a correct solution, right? So it's a solution we get, but if we plug it back in, it's not correct. So with radical equations, my point is, every time you get answers, you have to check them. You have to check them back in the original. We never really had to do that with any other. We didn't have to do that with quadratic equations. We didn't have to do that with linear equations that we did in grade 9 because there was no such thing as an extraneous root. But there is with radicals. So now that you sort of have an idea, tell me what you do with this one. What would you do first? Yeah. we always want to get the square root by itself, right? So we're going to subtract 5 from both sides. And what does that leave me? Square root of 2x minus 1 equals 7. Now what? Square both sides. Square and square root cancel out. And what am I left with on this side? And on the right? And now it's just a regular two-step equation. Add 1 to both sides. 2x equals 50. Divide both sides by 2, and x equals 25. But like I said, with these ones, you have to check. So going back to the original, does 5 plus the square root of 2 times what my answer is, 25 minus 1, equal 12? And notice I put a question mark because I don't know if it equals it yet. Yeah, so let's do this. 2 times 25, 50 minus 1, square root, plus 5, 12 equals 12. We're good. Good solution. Works. Okay, so that's all you do for these things. Get the square root by itself, square both sides, solve what's left, and check the answer. But of course, it's not going to be just that. Don't worry. Anyway, let's go back up here. So when solving radical equations, we must make sure to, I can't even remember what I wrote in there. What did I write in there? Oh, yes. Identify whether solutions are extraneous. And what is an extraneous root? Remember, root means the same as they're interchangeable. Is a solution that appears to be correct, but is actually not correct when we substitute it back into the original equation. And we've already discussed by going through that example. Okay. So isolate the square root, square both sides, solve what's left, check your solutions. Example 2. What would you like to do first? What do I need to do first? It's the square root by itself. No, it's got a minus x. Take this over to the other side by adding x. So it's going to be square root of 5 minus x equals 7 plus x, or x plus 7. Doesn't matter. Now, will one of you be able to catch this? That's the next step. Square both sides. So we're left with 5 minus x. What happens on the right? X squared plus 49?
That would have been 14x.
What is she talking about? Remember, you have to square the entire right-hand side. What does x plus 7 all squared mean? It does not mean x squared plus 7 squared. It means x plus 7 times x plus 7. Which is 4 multiplications. X squared plus 7x plus 7x plus 49. So that's what she was talking about. I know you did. I was about to say that you are, I just finished saying. It's not, you can't just square each term. You got to square the entire side. If you multiply an entire side, that's the same as multiplying each term. But if you square an entire side, that's not the same as squaring each side. Well, what do we got left here? What kind of equation we got left here? Quadratic, baby. Come on. Right there. That should tell you it's like quadratic. So that means I got to do the factoring thing. Or the quadratic formula thing, which is not so yay. Quadratic formula. It's quicker. Oh, that sounds like a dare. That sounds like a challenge. Sounds like a challenge. Okay. First of all, I got to get everything on one side, right? Well, the x squared is already positive here, so let's bring these two over. So I'm going to subtract 5, and I'm going to add x. So I'm left with 0. Equals x squared. I've got 14x, I added another x, right? 15x. I have 49 already here, but then there's a minus 5. Minus 44.
11.
Hang on. Whoa! Don't look at me that way, because Ayla and I have something to do here. So I'm going to solve it by factoring. Why don't you come up here and solve it by the quadratic formula? We'll see which one gets there. Yes, the quadratic formula will work, but look at it. Watch. Negative b, so negative 15 plus or minus 15 squared minus 4 times 1 times negative 44 all over 2 times. Don't look at her.
Wait,
2 times 1. What?
it might be silly, but I'm just why is it negative? Is it should be positive? Yeah. Yes.
Positive 44. Fine. Fine. Positive 44. Negative 15 plus or minus 225 minus what's 4 times 44? 88, 156? No. 176? I think it's 176. Over 2. Negative 15, as I keep going, plus or minus. That works out to 49 over 2. Negative 15, plus or minus 7 over 2. I got to keep going. Negative 15 plus 7 is negative 8. Divide 2. One of my answers is 4. Negative 15 minus 7 divide 2 is negative 22 divide 2. which is negative 11. Got my answers. Negative 4. Let's go up and factor. Okay? X plus 11 times x plus 4 is what it factors to. So, what value of x makes this? Negative 11. What value of x makes this? Negative 4. Done. The quadratic formula will work. Boy, that's a lot of extra work. And you know, in math, the more steps you got to do increases the likelihood of making a little mistake. And it's going to like double how long it takes you to write the tests already. Well, no, because you haven't done one like this before. And guess what? We're not even done yet. We have to check our answers. That's crazy. We got to check each one of these answers. So negative 4, what's the original question? Does or is 5 minus negative 4 square root minus negative 4 equals 7? Well, what's 5 subtract negative 4? 9 square root 3 plus 4, 7. Negative 4 is a good solution. Negative 4 is a good solution. How about negative 11? 5 minus, in parentheses, negative 11, then we square root it. Minus negative 11. Does that equal 7?
No.
16. Square root of 16 is 4. 4 plus 11 is 15, which does equal 7. Bad solution. Bad. Get rid of it. So that's a complete answer. Next one, interesting. What would you do here? What do you think you'd do here? Yeah. Each side has a square root on it and nothing else. If we square both sides, both of them will disappear. So just square both sides. Don't shake your head, just square both sides. Don't turn around and look at her, just square both sides. You know you can do this. X plus 5 equals 4x minus 1. Now it's just, there's no quadratic. Okay, it's an easy equation. Don't make it complicated. What are we going to do? All right. So you want to move x over here? Sure. 5 equals 3x minus 1. Add 1 to both sides, so 6 equals 3x. X equals 2. Temporary solution. Check. Does the square root of 2 plus 5 equal the square root of 4 times 2 minus 1? Doesn't matter. Does the square root of 7 equal the square root of 7? You bet. You don't need to calculate it. Good solution. Okay, the last example is one area where we can use these things. And are all of you going to go on to be, well, not necessarily mathematicians, but a sailor to determine the strength, who needs to determine the strength of the wind, whether they can put to sea that day? Okay? Not necessarily. Okay? This would also be a science problem. Okay? Are many of you going to be in this field? Probably not. Okay? But if you notice, as we get into older grades, some of the uses of what we do, especially in math, becomes very specialized. Okay? But we do all, like we do quadratic equations, that has applications in certain fields. Okay? We do radical equations, that has applications in certain fields. Next year we do logarithmic, we do exponential. This year we do trigonometric. We do all sorts of different types of equations. And they all have applications in different fields. A lot of times science, a lot of times business. Okay? And all sorts of science. We use square roots to determine the lengths of skid marks in accidents. Okay? We use square roots. So if you're a forensic person, you'd probably be using them. Or you'd have to have some kind of understanding of them. Is everybody going to be like a forensic analyst here? No, of course not. Okay? But the whole idea, you guys, is to expose you to all these different things. And then you get to decide what interests me, what do I'm not interested in, what do I absolutely hate. Okay? It's no coincidence that your grade 12 year ends when you become an adult at 18. Because now that you're an adult, you make your own decisions. So now you've gone through high school, you've seen all these, hello, I'm right here. You've seen all of these different things going on. You've made a decision. Yeah, I'm going to pursue this. And it may change. But how do you know what to choose if you don't see everything? You know, by what you hear, oh, I heard that, that accounting is really bad, so I'm not interested in it. Meanwhile, you could have been the best accountant in the world. Making millions. Traveling the world, giving accounting presentations. Anyway, that ends my little rant. All right. So here we have a formula that helps determine the strength of the wind. Okay. And what happens is we use a formula to make it into a number, a whole number. And that whole number determines how strong the wind is. So, and the formula is the wind scale number is equal to 1.33 times whatever the wind speed is, plus 10, and take the square root, subtract 3.49. So define the number for a 40 kilometer an hour wind. We just plug it in. And then you got to know how to use your calculator. In this case, we're going to be using our calculator. So what would you do first? Okay, so inside square root is root 50. Actually, you could do this all in one step. Do the square root of 50 times 1.33, subtract 3.49, and round that to the nearest whole number.
14.
Okay, I got a 6 and I got a 14 point something.
It can't be 14. From 0 to 12, 6. That's what I thought.
Do the square root of 50. Do the square root of 50. Got it? Just do the square root of 50. That's it. All I want you to do is square root of 50. Okay, times that by 1.33. Get that answer. Subtract 3.49. Boom. Okay. So probably just it may have misinterpreted the way you entered everything. It did different order of operations. That's why you gotta be careful when you enter these things in the calculator. Okay, because it's easy to get the wrong number. So that number is assigned to 6. Well, 40 kilometers an hour, again, it's moderate. Okay, I mean, it's not like hurricane or anything like that, but it's pretty breezy. So that gives you a 6. What about the second question where we're asked to work backwards? We're told the wind scale is 7. What does that translate to in terms of wind speed? Well, obviously, it's going to be more than 40 kilometers an hour. Because in the previous one, 40 kilometers gave us 6. 7's got to give us higher. How do we figure it out? How do we figure out the exact answer or the answer? B plus 10. I'll just put minus 3.49. So now you have to set up an equation to solve for V. Or X or whatever you call it. So now we've got a whole bunch of things to take over to the other side, don't we? Remember, let's get rid of what's furthest away from the V first. Well, the 10's right beside it under the square root. Then the square root, then this is furthest away. Let's add 3.49 to both sides. And we get 10.49 is equal to 1.33 times V plus 10. We don't have to write 10.0, we can just write. What do we get rid of next? Gotta be careful here. We don't want to square both sides yet because not everything outside the square root has been gotten rid of yet.
10.449 divided by 1.33.
Both sides by 1.33, you get the square root by itself. That's going to give us an approximate answer of, sorry, 7.89? Yeah. 7.89 is equal to V plus 10. Now you square both sides.
Right?
And you get V plus 10 equals whatever that is squared, which is what? I'm going to say 62.25.
Yeah.
Really?
Yeah. Wow.
I did.
Maybe you maybe minutes.
No, I've already told you guys what I would have been if I wasn't a teacher. Architect.
Really? Oh, I can see that. Wow.
Now what?
V subtract 10. V equals 52.
So 52.25 kilometers per hour is the equivalent to a 7 on the Beaufort scale. Oops, it's the
Do they still use this numerical scale?
Yeah.
Wow.
Yeah.
And the saber went to 6. Or is it 6? I think it's like 6. You can see that.
Yeah.
Oh, okay. It's 6. It's 6.
Well, yeah, because they could have machines that just sort of, they catch the wind speed and they calculate it to a scale number. Hang on. So for Monday, 3.7, exercise 3.7, please. And we're going to do 3 lessons in exercise or in unit 4 before we have our next test. I can tell you that like